Hello everyone, today we're going to be talking about how to use the brute force algorithm on Kn, the complete graph with n vertices, to solve traveling salesman problems. Okay, so what we're dealing with here is we have some sort of graph representing a traveling salesman problem. So somebody wants to get to, in this case, 4 different locations, and we've got weights associated with each edge. And to solve this problem, we want to find a circuit that visits every vertex such that the total weight of that circuit is as small as we can make it. So if we add up the numbers associated with the edges in our circuit, we want that to be as small as possible. And brute force algorithm is going to give us a way to find that minimal Hamilton circuit. The first step is you're going to list out all the Hamilton circuits of the underlying graph Kn. And this is the brute force part of it because you're just listing them all out. If we have n edges or n vertices, they're going to be n minus 1 factorial. So for this particular graph, n is equal to 4 and n minus 1 is 3. So we have 3 factorial, and remember it's 3 times 2 times 1, which means there are 6 that we're going to have to list out. After you've listed out the circuits, you find the weight of each one, and surprise, surprise, you choose the circuit with the smallest weight. Okay, so let's go ahead and deal with this example. It's the same graph we saw above, and we are going to pick a starting point and go from there. And let's fill in our labels, and we're just going to choose to start at A. Okay, and to make things sort of visually nicer, I'm going to draw out these Hamilton circuits, list them out in a particular way. Okay, so I'm going to start over here at A, and now from A we have 3 options. We can go over to B, down to C, or over to D. So I am going to write this like that. We can go over to B, we can go down to C, or we can go down to D. And we can go ahead and list those weights. So from A to B, that weight is 48. A to C, that weight is 28. And from A to D, that weight is 22. And now we're going to do the same thing for each of these vertices. So from B, if we come from A, now we've got 2 options. We can go to C or we can go to D. We don't want to go to A because we've already been there. So we can go up to C or down to D. And from B to C, that weight is 32. From B to D, that weight is 20. And let's go ahead and complete this. If we go from A to B to C, well, our only option is to go over to D, over to D. Let's be consistent here. And from C to D, that weight is 18. And if we've gone A, B, C, D, well, we need to complete the circuit. The only way to do that is to go back to A. And that weight is 22. And let's go ahead and do this for this circuit too. If we've gone A, B, D, well, our only option, the only vertex we need to visit is C. So we go over to C, that weight is 18. And from C up to A, that weight is 28. Now we're going to do the same thing for each of these other branches. So if we start at A and go down to C, well, we've got 2 options. We can go up to B or over to D. So let's draw those 2 options. Up to B or over to D. And if we go from C up to B, that weight is 32. If we go from C to D, that weight is 18. And now if we go A, then C, then B, A, C, B, the only vertex we still need to visit is D, and then completing the circuit we go up to A. So we need to visit D and complete the circuit over to A. B to D, that weight is 20. And D to A, that weight is 22. Now, if we go A, then C, then D, A, C, D, the only vertex we haven't visited is B. So we're going to go over to B. The weight of that edge is 20. And to complete the circuit, well, we've hit A, C, D, B. Completing the circuit, we go back to A, and the weight of the edge from B to A is 48. And now our last branch down here, if we go from A to D, well, we've got two options. We can go over to B or down to C. So over to B or down to C. If we go from D over to B, that weight is 20. From D down to C, that weight is 18. All right, now A, D, B. If we've gone from A to D to B, the only vertex left to visit is C. The weight of the edge from B to C is 32. And the only option, if we've gone A, D, B, C, to complete the circuit is to go back up to A. So you'll notice the last edge in all of these is always the edge that takes you back up to A. All right. And now the last branch here goes A, then D, then C. So A, then D, then C. Now our only option is to go up to B. The weight of the edge from C to B is 32. And then to complete the circuit, we always go back to A. And from B to A, that edge has weight 48. So we've listed out 1, 2, 3, 4, 5, 6 Hamilton circuits. They all are circuits. They all visit every vertex exactly once, except they start and end at the same one. Now what we're going to do is compute the weight on each one. Okay, so we're going to add the weights together. So for instance, on this first branch out here, this one we would do 48 plus 32 plus 18 plus 22. Okay, and that is going to give us, this circuit has weight 120. All right, now the next one, A, B, D, C, A. We take 48, 20, 18, 28, and add them together. And what we get is 114. And we're going to repeat that with every single one. So for A, C, B, D, A, we would take 28 plus 32 plus 20 plus 22. And for A, C, D, B, A, C, B, D, A, we get 102. And going across this next branch, A, C, D, B, A, we add those together, 28 plus 18 plus 20 plus 48. And what we get is 114. And now we need to do the last two branches, A, D, B, C, A. We add those together. Oops. And we get 22 plus 20 plus 32 plus 28. If we add those together, what we get is 102. And the last edge, 22, 18, 32, and 48. When we add these together, we get 120. All right, so we have the total weights, and we want the one with the least cost. So we're gonna pick the smallest weight. And what we'll notice is that smallest weight, and in fact, every other weight appears twice. And the reason for that is that there are 6 Hamilton circuits, but there's actually 3 pairs of reflected circuits. So we'll notice the circuit corresponding to this weight of 102 was A, C, B, D, A. A, C, B, D, A. And the one corresponding to the other 102 was A, D, B, C, A. A, D, B, C, A. So they're just the same circuit, the same edges, but reversed, right? A, D, B, C, A. So either one works. It's a Hamilton circuit that takes you on a minimal path. And that is it for today.